So it's given here that a plus b plus c equals to pi radians. Then we need to show that sine of b plus c minus a added to sine of c plus a minus b added to sine of the angle a plus b minus c is the same as 4 times sine of angle a, sine of angle b, and sine of angle c. Okay, so let us begin. Now this is a problem of conditional trig identity. Now, let's say we have a trigonometric identity given by sine squared theta plus cosine squared theta, and we know this equals to 1. Now, this is an identity because it's going to be true for any value of theta that we choose. However, for our case in this problem, this is a conditional trigonometric identity because it's going to be true based on the fact that if we take the sum of the three angles of a triangle A, B, and C, the sum must add up to pi radians. Only then we can say that the given trig identity is going to hold true. So our goal will be to verify that this is a true statement using the fact that a plus b plus c equals to pi radian. Okay, let us begin. So we'll start a proof from the left hand side. So here on the left hand side we have sine of the angle b plus c minus a. Now what we'll do, instead of writing it as b plus c minus a, we're going to add and subtract a, which is an extra term here. So we have a plus b plus c. So what we'll do, we're going to subtract a because this is an extra term that we are adding here. Now we are subtracting, but we already have another negative a present, so that's going to make it negative 2a. Now let's go to the second term where we have sine of the angle c plus a minus b. So here what we'll do, we're going to add a plus, we already have a, but this time we're going to add a b to it. So we have c already present. Now b is an extra term that we're adding, so we have to subtract b from it. But negative b is already present, so we will get negative 2b. And then for the third term we have sine of a plus b minus c. We can rewrite it as a plus b plus c minus 2c. So c being an extra term that we are adding and subtracting. Okay, now what we can do, in place of a plus b plus c, in each of the three cases, we can replace it with pi radian. So we get sine of pi minus 2a added to sine of the angle pi minus 2b added to sine of the angle pi minus 2c. Now we have a standard formula. We know that whenever we have sine of pi minus some angle theta, that's simply given by sine of that angle theta, and it's going to stay positive because pi minus theta means we are in the second quadrant where the sine function is positive. So sine pi minus 2a, that's going to give us sine of 2a added to sine of 2b added to sine of 2c. Okay, so what we have done, we have reduced our original expression on the left hand side to the sum of three sine function. We get sine of 2a, sine of 2b, and sine of 2c. And we have already showed that sine of 2a, sine of 2b plus sine of 2c, that's equivalent to 4 times sine of angle a times sine of angle b times sine of angle c, provided a plus b plus c equals to pi radian. So here you can check out the first video where we have already worked out this problem, and I'm leaving this as an exercise for you to try out. This is going to be equals to the right hand side. So here we have successfully verified that yes, it is true. That means the left hand side is going to be equals to right hand side, provided we have the condition that a plus b plus c equals to pi radians.